Iain McGilchrist gave several lectures and had a whole event at Ralston College about AI and the battle for the soul, which was very exciting and very insightful. And obviously, Mr. McGilchrist is right on all accounts. And there's a lot to learn from him. In fact, I heartily recommend everyone to read Iain McGilchrist's book, The Master and His Emissary, for everyone who wants to understand the current AI large language models and their get some kind of an idea how to think about those. I do not recommend The Master, The Matter of Things so much because that book is intellectually insulting in a way that you feel small and belittled by the sheer magnitude of what this volume presents. But I want to give a few details on what AI really is and what we're talking about here, kind of a prerequisite or the prelude to the actual presentations, because a lot of talk about AI happens without really thinking about what it is and why we want to be wildly optimistic about the future. And that's the one point where I deviate from what Mr. McGilchrist presents, because I believe things are getting really good. Now, here's the thing. We, that is humanity, the general public, the West, got hit with AI in a rapid fashion in these last years. It's kind of a blink, and systems were available that we didn't dream of before. And it all started, if you remember, a couple of years back with systems that could recognize pictures of cats and dogs and tell you whether it's a cat or a dog on a certain image. That was amazing, exciting, and from a computer science perspective, kind of an unheard of feature, because it did work really well. And looking closer, it turned out that the magic in this whole setup, or if you follow McGilchrist, the anti-magic, the thing where the magic really is taken out of the system, was the ingenious way how the engineers, the inventors, managed to map pictures of cats and dogs into numbers. Internally, it's all just numbers, and in particular, linear algebra. It's the stuff we know from high school. And the magic, as I said, is that they found that you can map this domain, pictures of cats and dogs, on top of a couple of large, very large sets of numbers, and then calculate percentages of likelihoods, whether it's likely a cat or likely a dog, and sometimes it's a very high likelihood, and you're confident to say, yeah, probably cat-like, and something not. And this used to be a toy in the very beginning. However, very quickly we learned that now that this toy exists, we can build self-driving cars. One of the major challenges in self-driving cars is to see the environment and have an idea what is going on there, and as a basis for making driving decisions. Now, it turned out that building self-driving cars has a couple more technical challenges than just computer vision. But computer vision was a very important problem to be solved, and it seemed that the AI systems, that is mapping pictures to numbers and likelihoods was a kind of a prerequisite for self-driving. Now, looking closer at this AI thing, it turned out that all we do there, and the computer vision system is most illustrative for that point of view, is math, is statistics. And what happens is that we kind of feed a large number of pictures into a system, tell the system whether it's a cat or a dog, and then make a statistical ball of numbers that allows us to query it with similar pictures and then get a likelihood whether or not it's likely to this group or that group. And the amazing thing here, from a intuitive perspective, is that it works so well that the mapping of pictures to sets of numbers, in this particular case, reproduces likelihoods and similarities in a way that humans recognize it easily, but we don't know of an algorithm to map out those likelihoods more directly rather than statistically, as these systems do. But that setup means what happens here is that building an AI system requires a huge number of input data, some black box mathematical machine that does a lot of computation to build a large ball of numbers. That large ball of numbers is the model, and it includes this particular knowledge of the particular sets of pictures it has seen at the beginning, and then this ball of numbers can be queried again, which is again a mathematical operation, but it's much faster and much less computational intensive to make a simple query on this ball of numbers. Here's a picture. What do you think? It's more cat-like, more dog-like. What's your opinion? So structurally, we have a lot of work to do, numerical work to do, to build up such a model, and they call it model. Why not? And then once the model is there, it's a matter of querying it, like asking, giving it another set of numbers, asking it. And the way to think about that, in the most primitive sense, really, is high school interpolation. We have a couple of points we know about. We construct a curve through that couple of points. And now that curve allows us to guess the value for other points that we didn't have in the original set of points we specified. That's what it is logically. And from there, it immediately follows that if we take a point that's way out there and has nothing to do with the original set, we get some garbage data back. We hardly get, or this is out of range, we cannot handle it. The math gives us some numbers back. That's how math works. Now, that's just the very beginning. And as I said, they hit us with computer vision. We started building autonomous cars, trying to, and I have been involved as a computer programmer, as an engineer. I have been involved in some of the lesser attempts to go there. And shortly after, they enhanced the AI models to not just recognize pictures, but generate pictures, generate movies, generate voices. It's kind of all following the same logic of a lot of data in, building up a model, which is a lot of numbers in a structured manner, and then querying that set of numbers and producing some output. Now, that seemed cute. The industrial application seems to have been, well, the movie industry for one, but big marketing for another. And as a direct result, we are now faced with a virtual reality that has hardly any relation to reality anymore, because all the movies, all the voices, everything we see on TV, on social media, we don't know whether it's true or not, whether it has any resemblance to what actually happened in the real world, or whether it's just made up stuff by computers. So there's where the reality went out the window. And then, and here's the like exciting, most interesting part. They pulled large language models out of the drawer somewhere, and large language models came as like it started all with the OpenAI Foundation, which was a non-for-profit organization in the beginning, because they knew what they were doing. They knew they wanted to model language, and in order to model language, they needed to feed all the language of the world they can take into their models. Again, the principle is roughly the same. A lot of data, sophisticated setup of models, and statistically querying that large language model is nothing but asking it for the next word, roughly speaking, again and again, and thereby building long sentences and paragraphs and texts. It's all just statistics. Now, if you interact with it, it feels magically, for sure, because it seems to be responsive to text represented, questions you presented, and it answers back in a sensible way, and it seems to have an enormous ball of knowledge behind it to go and answer all kinds of things. Now, it may lie to you easily, because some things it just doesn't know, and it doesn't know in this way, in the most primitive form. And these engineers, obviously the systems that are available now are a little more sophisticated and try to guardrail and all of these things. But in principle, it's still statistics. The central engine, what actually makes it tick, is statistics, and there's no thinking in there whatsoever. So if we are now afraid of these systems, we are kind of afraid of math, and that seems silly. That's my first and major point. Being afraid of math isn't the right way to think about the world. So it's not math we are concerned about. We are concerned about a lot of other things, and those are not, in fact, the AI model. Let me continue the quick thought here. We are currently at the large language models as the most prominent AI category, and the one that takes people, makes people wonder what is going on. And we have this realization that it's still just math, and it's math on like the knowledge of humanity, if you will. These companies, these organizations need to get all the books in the world and stuff them into their mathematical notion to build the big model, the big database of knowledge, what humanity produced up to this point, which, if you think about it, can be very useful to have the knowledge of humanity at your fingertips. Can be very exciting, unless, of course, it's hidden away behind a paywall and belongs all of a sudden to some company no one asked for. And this is where things are getting interesting, because these models, these systems prove to be interesting enough and useful enough that we will not stuff them back into the box and pretend it never happened. But on the other hand, we cannot and will not allow some company that some dude somewhere in California spun up because he was closely associated to people who knew and got the funding and got the inside knowledge to do so. We will not allow such a company to just own the knowledge of humanity and everyone pays a subscription fee for forever to be allowed to access the knowledge that belongs to all of us. That's not how we do things. But it seems that's one of the possible futures. So we need to be careful. We need to have the discussion at hand. Now there are people out there that are now claiming these large language models are not the way, technically not the way towards general artificial intelligence, and we need to have even harder, even different systems. So I don't rule out the possibility that in a few years hence we are talking about even more sophisticated systems that do even different things, and I have no insight in any of that. So we'll stick for the current discussion to what we have available right now. And it's fascinating. Just last year, 1 year ago, summer last year, we saw an interesting graph that the usage of ChatGPT, the big large language model that dominated a year ago, the usage of that model dropped dramatically once summer started and school ended and the students went to their summer vacation. Which means at this time, the most important use case of said large language models was to generate student work, which teachers are very concerned about. Students liked it very much, apparently, and we should have and can have an argument, a discussion about what this means for education and how we go forward from here. Pretending it didn't happen is probably not the right approach. But this year things changed. And they hit me personally in a way that I didn't see coming, as in my daily work as a software engineer. I'm writing software for a living for lots of years now. And starting this year, starting January, I'm using the artificial intelligence tools heavily. That didn't happen last year at all. And last year the thinking was that computer programming, low-level computer programming, was hard and difficult, and therefore only to be done by specialists and not accessible to automated tools on computer side. This year it's obvious that the large language models are totally able to build sophisticated systems with some guidance from a human being. Some oversight is required still. And changing the job description tremendously. Now, there have been people pointing out that this development killed entry-level jobs, and a lot of layoffs happened because of AI and that kind of a thing. I'm cautiously You know, I'm not too sure that correlation and causation really fall together in this case. We may have an economic downturn, and AI may be a good talking point of why people are not hiring and that kind of a thing. Let's see. It seems to be the case up till now, and that's half a year is not a long time at all to make predictions on. It seems to be the case that thinking, even in computer programming, is still required on a human from a human perspective. However, the low-level stuff seems to be easily manageable by the system. And it's really remarkable thinking that we fill in those blanks, those logical systems based on statistical models that do nothing but interpolate from logical systems they've seen before. And we seem to be in the middle of a big job reset for software developers. Now, that seems to be sad, and it seems to be a bit of a problem because Peter Thiel told us a couple of years back already that since the 1980s, software development, computer programming, computer science in general was kind of the only field in the general engineering range of fields that paid off. All the other fields just didn't do much. I'm a civil engineer by training, and I didn't see much opportunity in civil engineering to advance my career or build interesting things. There was no money, no excitement, no nothing. So it was very easy to pivot into computer programming and do interesting things in front of a screen, trying to get the system to behave and all that kind of a thing. Now that seems to change, and it's not obvious how, in which way. But on the other hand, we may not want to be too sad about it. In the last years, and that's especially peaking probably just before the pandemic hit in 2020, computer science and computer programming attracted more and more people, and we had companies with rooms full of desks, and each desk 2 screens, and in front of each screen one poor guy typing away happily, building some kind of logic into the computer system. And that cannot go on forever. We cannot as humanity, as society, just consume more and more of our resources into building computer stuff, building software to run on computers. That cannot be the productive use of human ingenuity. So if we have a way to offload a lot of that intellectual work to computers, that's a good thing, provided there's oversight, provided that the people that are freed up have the ability and the insight to do something more worthwhile. Now there's this issue about money and about compensation and feeding everyone and getting everyone as part of the community. And yes, that needs to be discussed. We should not allow some large corporations to get all the funds and get all the resources as a result, and have people outside be starving. That's is a real issue, and that's basically the same issue behind the AI debate as well. So there is something on a societal level that needs to be discussed. And the AI tool seems to be kind of a linchpin situation where things are starting to get very, very obvious. Because why should any large company be allowed to profit immensely from the accumulated knowledge of humanity, even in a field like computer science, where these models are that good, they're reasonably good, not amazingly good, because they've seen all the things that people have built before. So the matter we have here is a matter of what's, from a moral standpoint, looks like a robbery. And that robbery cannot be allowed. Now, it may be legal at this point in time, so we have to talk politics again, and we have to talk law again. And this may be what Chesterton meant when he said that only theology and politics are worthwhile to discuss. There have been a lot of jobs lost that nobody does anymore. Jobs in the old days that people were occupied in, and no one cares. And people will have new occupations. And what matters is to get people to use their intelligence and ingenuity that in a way that goes beyond what computers can do. On a personal side, I found part of what the machine does to be really relieving. I had difficult days in my in my programming career, days when I didn't spend building things, which is exciting and always very inspired, but where I try to find bugs and try to find defects and try to get things right that were not quite right before. And it turns out that you can delegate this task pretty nicely to the machine, as long as the defect is reproducible in a way that the machine can see it and then iterate and find the root cause and suggest solutions and stuff like that. And basically the insight here is that computer programming isn't such a high intellectual activity as we thought it was. It is just filling logic into a box that is very, very left brain work. There's no there's some inspiration needed, and some thinking outside the box is needed to know what you need to do, to know what kind of a system needs to be built. And that's the exciting part. And that part, amazingly, isn't going away. That is not the part the automated systems take from you. But the grind, the building all the lines and making sure the logic on a smaller scale is sound, that's something the machines seem to be incredibly helpful. Now, that being said, the issue with AI, one of the issues with AI, seems to be who owns it, what role does it play in our daily life, and how do we interact with it, and what place do we assign to it. And it is true, there are people that fall deeply into the AI trap and give the AI system a name and give it an imaginary personality and like fall in love with it and have the illusion they are talking to a person here. And these are people that seriously need help, because they are have some kind of a damage that I'm not able to diagnose precisely. So there's danger here. And there's danger that we tell it too much, we integrate it too deeply, we forget about the actual world, our actual relations to real human beings. All of that. There's the economic aspect of it, who owns it, who profits from it. There's even, and that's where things are getting really interesting in the current scape, there's even the question whether the AI systems as they stand right now will be maintainable in the long run. And the guess is they won't. They won't because building and running data centers seems to be very expensive, and there seems to be some craziness going on right now with creating more data centers and more pollution along the way. And I'm not. I'm wondering why data centers are supposed to consume so much water. I don't see a technical need for it, but I may be just uneducated about it. I see that Elon Musk wants to put data centers in space, and even though I'm all for space exploration and growing humanity into that dimension, I didn't get the full impact, the full idea what is going on here, why that should be a good idea, and how it's supposed to work. Now, that's kind of long-term vision. In the short term, we know that these AI companies, and there are only a few now, don't really make money on the product they sell. They get a lot of money, but their expenses are way higher. And these expenses are, for the most part, data centers. And it seems the big tech companies, all of them, excluding Apple, are just hemorrhaging money now. These companies seem to have had a business model that made them extract money from humanity for a long time. And now, thanks to data centers, whatever that term stands for, we seem to be in a situation that these big tech companies are just giving back all their revenue of these last years. And I'm not sure whether I should be happy or sad about that. It seems to be rather somewhat correct to not allow those companies to be, there was some unfairness going on. And we seem to be in a situation where that's somewhat corrected. I'm wondering because the famous Anthropic company that's dominating the code generation large language models at this point in time seems to be not on financially good grounds, and it may be, and I don't know, but it may be that that company will have considerable trouble going forward to find sufficient data centers to run their models on to satisfy their customers, and asking their customers for enough money to build data centers and be profitable seems to be, in this case, using real humans instead of the machine seems to be the more economic version. Now, there are more question marks than answers in this on this economic front. What seems to happen is that the Apple company and others following along seems to work on hardware that allows to run these models locally, and that seems to be the right way to go. One of the ways to go, and certainly the right way from a humanitarian point of view, that if you need, you can have your own large language model running on your own desk. All the psychological questions remain, and a lot of left brain, right brain discussions remain, but the economic and power distribution questions change a lot, and that's what I'm hopeful for a start. We know that these models, once they exist, can be easily copied and distributed. And even though those models are very large, they have a size that allows distribution. And if it's possible to run those things locally, we distribute real power to people. And we may just end with an amazing tool that in the end frees humans from low-level left brain work, some of it. Adds new dangers and adds new challenges. And I don't want to advertise this as the bright new future that we're all waiting for. We will have to have more conversations about that and find ways and maybe even agree to not give these things into kids' hands, and maybe agree that we need to keep it out of education. Maybe agree that that's not a good thing for private consumption. I don't know. But such an agreement needs to happen on a societal level, not dictated from an all-powerful company that just decides who gets access and who does not. And for this to happen, we need to have an evenly distributed system. Now, this doesn't answer how living authors need to be compensated, and this doesn't answer how the authors of all the ingenuity that went into those models need to be participate. There's a lot to think about and a lot to negotiate. In the grand scheme, it seems that we have the ability, technically, to give a pretty amazing tool to people that may open the door to interesting research in different areas, and then make computer science a lot less attractive for people and free people up to do more amazing things that are outside this box. And that's all I can say at this point. And this may not warrant my overly and my enthusiasm, my optimism. My optimism really grounds in the fact that we have Iain McGilchrist and we have people that finally tell us how things work and what to be careful about. Because having that knowledge available is the first step to reconstruct society in a way that actually serves people. And that's the point where it's really starting to get good. So here we are.